All right, let's talk Java. Sometimes the simplest tools, the ones we use every day, like strings and arrays, are the ones that hide the most surprising little secrets. Getting them wrong can lead to some really subtle bugs and code that just crawls. So today, we're going deep on how they really work so you can start writing cleaner, faster, and way more solid code. Okay, let's kick things off with a classic head-scratcher. You've got a string with some pesky whitespace you want to get rid of. You call the handy trim method, you expect it to clean things up, but then you look at S again and what? The spaces are still there. What in the world is going on here? To crack this little mystery, you first have to understand the fundamental nature of a Java string. See, it's not just a bunch of characters. You should think of it more like a signed contract. Once it's made, its terms are absolutely non-negotiable. And the key technical term here is immutable. It's a hugely important concept. It just means that once a string object is created in memory, its content, that actual sequence of characters, can never, ever be changed. Not by you, not by Java, not by anyone. And hey, don't just take my word for it. The official Java documentation says it right there in black and white. Strings are constant. So think of every single string you create as being set in stone. This one design choice affects everything else we're about to talk about. So this brings us to that aha moment that solves our puzzle. Methods that look like they're changing a string, like .trim or .uppercase, don't actually touch the original at all. What they do instead is create a brand new string object, make the changes to that one, and then hand it back to you. And that's the fix. It's so simple once you see it. You have to catch that new trimmed string that the method gives you and assign it back to your variable. You're not changing the old string, you're just telling your S variable to stop pointing at the old one and point at this new, clean one instead. That's immutability in action. Now, this whole idea that operations create new objects, well, that leads us right into one of the most common traps in all of Java: comparing strings. You might think you know how to see if two things are the same, but it's a little trickier than it looks. See, you've got two tools for this job, and they are not interchangeable. The double equals operator, double equals, is basically asking, are these two variables pointing to the very same object in my computer's memory? Meanwhile, the dot equals method doesn't care about memory locations. It asks, do these two strings contain the exact same sequence of characters, letter for letter? And this is why this line of code right here can be so confusing. New string test equals test is false. Why? Because you've created two separate objects that just happen to hold the same text. Their content is the same, but they live at different addresses in memory. So here's the golden rule. If you want to know what's inside the string, you always use dot equals, period. Okay, so what if you're building up a really long string from lots of little pieces, maybe inside a loop? You could use the simple plus operator. I mean, it works. But that's like trying to build a deck with a manual screwdriver when there's a power tool sitting right next to you. Remember immutability? Well, every single time you use plus to tack something onto a string in a loop, Java has to create an entirely new string object behind the scenes. If your loop runs 1,000 times, you're creating 1,000 temporary throwaway objects that the garbage collector has to clean up. It's just incredibly inefficient. The real power tool for this job is the StringBuilder. It's designed to be a mutable or changeable string. The workflow is simple. You create one StringBuilder before the loop starts. Inside the loop, you just append to it over and over again. This is super fast. And then, only when you're completely done, you call .toString to create that one final string object. And I'm not talking about a small difference here. The performance gap is staggering. StringBuilder is optimized for exactly this scenario, and it will run circles around simple string concatenation, especially as your loops get bigger. It's the professional tool for the job. Now, you might also see its older cousin, StringBuffer, floating around. The only real difference you need to know is that StringBuffer is thread safe. That safety adds a bit of performance overhead, though. So, for the vast majority of modern code where you're just building a string on a single thread, the faster StringBuilder is the one you want to reach for. All right, let's switch gears. We've talked a lot about the text itself. Now let's talk about the container, the array. I think the best way to picture an array is like an egg carton. It's a container that has a fixed number of slots from the moment you get it. So just like that egg carton, an array's size is set in stone the moment you create it. If you declare an array for 10 integers, it will always have exactly 10 slots.
You can change the eggs, or integers, in those slots, but you can't magically add an 11th slot. The size is fixed.
Now here is a tiny, tiny detail that trips up literally everyone at some point. To get an array's size, you use the .length property. Notice no parentheses. For a string, it's the .length method, with parentheses. It seems small, but remembering that distinction will save you from so many silly compile errors.
And hey, does this look familiar? Just like with strings, using double equals on two arrays just checks if they're the exact same object in memory. To actually compare the contents of two arrays to see if they hold the same values in the same order, you have to use a special helper method, arrays.equals.
Okay, let's bring it all home with a quick fire round. We'll look at some of the most common mistakes people make with strings and arrays, and the dead simple fixes for them. Ready? Ah, yes, the infamous array index out of bounds exception. We've all been there. This happens when you try to access a slot in your egg carton that just doesn't exist. If an array has a length of 3, its slots are numbered 0, 1, and 2, there is no slot number 3. The fix is a fundamental rule you just have to burn into your brain. The last valid index is always the length of the array minus 1. Your loops and your direct accesses should never go to length, they should always go up to less than length.
So, let's boil it all down. What did we learn? 1. Strings are immutable contracts. 2. Always compare what's inside a string with .equals you. 3. StringBuilder is your power tool for building strings in loops. 4. Arrays are fixed-size containers that use the .length property. And 5. Use arrays.equals to see what's inside them.
Look, by understanding not just what these tools do, but how and why they work the way they do, you've unlocked the ability to write so much better code. Code that's cleaner, way more efficient, and just plain works. So the only real question left is, now that you've really mastered the tools, what are you going to build?